Hello, and welcome to Game Revolutions, the series where we explore 1980s era video game development techniques by writing our very own Moon Patrol clone for the TRS-80 color computer using 6809 assembly language. A Moon Patrol clone which, over time, has begun looking less and less like Moon Patrol and more like my unhinged subconscious. Last time we successfully added a punishment to the user for not defeating the big boss in the form of a quantum ray, which can grab an alternate Earth and slam it into the moon. But one thing we didn't do is reward the user for getting through all the layers of the shield. Today we get back to basics with a simple assembly language looping pattern that can be built on for any purpose. We then expand on it to form a true 8-bit CGI special effect to make the big boss implode, as if a black hole were spawned at its center. Finally, we explore the implementation for a few options for the next special effect, the Kablooey. If you come from a language like C or C# or Java, there's a structured way to do a loop that you've probably gotten so used to doing that you can start typing it out before even thinking about what you want to do. The structure forces you to come up with a one-time initialization, a condition you check before entering the body itself, and then the update you do before branching back up to repeat. But when it comes to assembly language, the only structure is whatever you force on yourself, and there are so many ways to go about this. So this is the primary structure that I landed on when doing loops in assembly. I have one-time initialization that I do at the top, and then I add my label. This is where we're going to branch back up to later on to repeat each iteration. Immediately after that label, we put the body of the loop, and then finally we do our update. This would involve modifying some loop variable and then doing a conditional branch back up to here. For our example, we're going to write a loop that takes the top row of this car and copies it down here underground. In this display mode, each byte can hold 4 pixels, and so it takes 5 bytes to span from the left to the right side of the car. So again, we're just going to have a simple loop that will take 5 bytes from the top, stick it down here. Here's my starter file without any loop code at all. We load up the picture, and this just sets the display mode so we can view the picture. And we just halt here infinitely when we're done. So all of our code is going to go in here. And I'm going to write out our markers. This is where I initialize. This is my loop iteration, my body. And then here I'll do my update and my conditional branch back up. In the initialization section, I'm going to need a loop variable. And so I'm going to make it be A, and I'll load it up with 5. What I'm doing is something slightly different from what people normally do. I'm kind of starting at 5, and I'm decrementing my loop counter, and I keep going as long as I is positive. There's no reason you have to do it this way, but there is something nice about this that you'll see in a minute. Each iteration through this loop should handle a single byte. I'm going to read a byte from some source pointer, and I'm going to write that byte to some destination pointer. I do need to get X and U set up first, but I'll take care of that in a minute. The rest of my loop structure requires that I do my update, so I'm going to decrement A. And as long as A is not 0 yet, I'm going to branch back up to the label. By starting at 5 and decrementing each way down, I don't have to add an extra compare. All this would do is set the condition code register based on how A compares to 0. But the dec A already updates the condition code register for me. So by starting at 5 and going down, I get to save an instruction. If instead I started at 0 and I incremented A, then I would have to have a compare. Did I hit my 5? So this way is a bit more efficient. So that's basically the structure that we have. So all I need to do is set up my source and destination pointers. I just happen to know that the car lives at 21C3. And my destination is just going to be 20 rows below X. Each row consists of 32 bytes, so this sets up my U register to be the destination. So that's my new code. When we're all done, we're going to infinitely halt over here. So let's watch it in action. So here is the first top row of that car. It just consists of this little red dot here and then all of the green background. So let's extend this to the rest of the car. We've gotten one row taken care of. So what if we added an outer loop to apply what we did here to all of the rows underneath? We're going to apply the same pattern, but this time making all of this the body of an outer loop. So let's just adjust some of these comments here. So now we need to do an outer loop in it all the way at the top. And since this acts as the body of the outer loop, we're going to give it the label. Let's add a couple more inners here. And then down here is going to be our outer update and conditional branch. I'm going to set X up actually outside here at the beginning. This is going to be my very first value of X. But through the outer loop, we're going to update X to go row by row. So X is really going to become an outer loop variable. U will as well, but I'm going to keep this here because we're going to continue to base U off of X. So each time X gets updated, we're going to rerun this and make sure that U is always 20 rows below. Now we're going to need some kind of outer loop variable, but we're running out of registers. Both of our 8-bit registers are now in use. So I'm just going to use the Y register. I happen to know there are 11 rows to the car, so we're going to start Y off at 11. And then down below when we update it, we'll decrement it by 1, and then branch up to the outer loop iteration if it's not 0 yet. You'll see we're treating Y differently because it's an index register as opposed to a simple 8-bit accumulator like A and B. We're going to need to continue to move X down row by row, otherwise this outer loop isn't really doing anything other than just repeating the top row 11 times. So I need to move X down to the next row. But that's not quite right because I've been advancing X to the right byte by byte. So I need to compensate for the fact that it moved to the right by 5 bytes. And this should have me now starting at the beginning of the next row rather than the end of the next row. And since I left this adjustment of U up here, that means that as soon as I branch back up for the outer loop iteration, I will then base U off of the new value of X. So U will go down by a row as well. And there we have the copy of the car underground, like some kind of subterranean vehicle. So just to review, when I do this pattern, I divide my loop into 3 pieces. The one-time initialization before the label, with the loop variable set to the max value, then my label in the body, and then finally I update my loop variable with a decrement so I can immediately do a conditional branch right after to go up to the label. I'll note that this is not necessarily the most efficient way to do the one task I'm trying to do, which is make a copy of the car. But this is always the pattern of loop I start with, and then maybe I'll find some ways to optimize it here or there. And so now on to our game. If the player manages to penetrate all the layers of the shield and hit the boss, I'm thinking of having 2 steps to the animation. In the first step, rows above the middle will start pushing down and rows below the middle will start pushing up. Kind of like it's squeezing from the ends down to the middle. Like there's like a black hole in the middle and it's just sort of sucking everything in and getting it to implode. And once it comes all the way down to a single line, then I'm going to have like rays shooting out, like some kind of explosion. So for that first part where we just sort of slowly implode, I already have some code ready. Let's take a look. In the handle car bullets routine, which is responsible for drawing all of the bullets and adding new bullets when the fire button is hit, I've added a temporary jump so that as soon as a bullet is drawn, we immediately move to the sequence where the boss gets compressed. That sequence is handled by a triply nested loop. I'll refer to these loops as level 1, which is the outermost loop, level 2, which is the next layer inside the outermost loop, and level 3, which is the innermost loop. And in fact, level 3 is 2 loops. They're not nested, we just have level 3A running all of its iterations, and then level 3B running all of its iterations. 3A runs against the upper half, and 3B runs against the lower half. Each iteration of 3A simply takes a word, that's 16 bits, which is 8 pixels, from somewhere in the upper half, and it copies a word from the row above our current row into our current row. The body of that loop is very tiny. Here we just grab the word from the row above, copy it to the current row. You'll see that we increment our pointer to the next word to the right, decrement the loop counter, and branch back up. So a single iteration does a single word. 3b does the mirror image of this, but for the lower rows. It takes a word on the row below the current row and copies that word to the current row. And the loop is right here. Take a word from the row below the current row, copy it to the current row, advance our pointer to the next word to the right, decrement the loop counter, and repeat. So if each iteration of level 3 handles a word, each iteration of level 2 handles an entire row. So level 2 runs the full loops of 3a and 3b for really a pair of rows, one of the upper half and one of the lower half. And here's the code in the update for the level 2 loop. We rewind u back to the beginning of the upper row, move it up, and store it back. And we do the same for the lower row, except we move down one. So you'll see there's some self-modified code to restore u with the value of the upper row just before we run the level 3a loop. And below that, some code to restore u with the value of the lower row before we run the level 3b loop. And if level 2 handles an entire pair of rows, level 1 handles the entire figure. So level 1 starts our row pointers at the center, and the pointers fan out toward the edge, compressing the pair of rows above and below the pointers to the pointers. So if one iteration of level 1 handles the entire figure, multiple iterations of level 1 will simply repeat that process over and over again, so that each time through the figure gets compressed more and more and more. For the outermost loop, I have the loop variable just sitting on a stack. I initialize it with the value of the height of the boss divided by 2 plus 1. So that's just the number of steps we need to take to fully compress it. I decrement that counter and branch back up if it's not done. Otherwise, if we are done, we just restore the stack and just infinite loop. 1, 2, 3. Okay. Good enough. For the next part, it's time to make some rays shoot out. Well, I did enough of this to know I don't like it. So I'll show you. It's not working, but even if I could get it to work, I could see now this just looks pretty anticlimactic. I think it needs to be a messier explosion. I thought it might be cool if it were just super smooth, but no, it needs to shrapnel. We need shrapnel. Here's what I got so far. When it's time to animate the boss destroyed sequence, I skip over the whole compression implosion phase, so I can immediately start running the new code, which at a high level is just a loop that will add a new piece of shrapnel, move all the shrapnel on the screen out from the ship, decrement our loop counter, wait for a little bit, and then loop back up. Each piece of shrapnel is represented by an instance of this struct. A piece of shrapnel is 2 by 2 pixels, so I use 1 byte to hold the bit patterns for those 4 pixels, and this is simply chosen at random. The x and y coordinate of the corner of that pixel box, and these describe how this piece of shrapnel moves. On each step I add this to the x and I add this to the y. These are also chosen at random. One of the nifty tricks I learned from Bosco and from others is if you have 2 8-bit fields and you tend to load or store them at the same time, you can save some cycles by just using the D register. So for example, here I load D with the starting position for x and y, and then I store it into both fields, starting at x, but it will include y since this is 16 bits. With indexed mode addressing, my base cycle count for a store of 8 bits is going to be 4. So 2 stores would be 8, compared with just 5 for D. Anyway, I keep an array of the shrapnels over here, and the new shrapnel, if necessary, checks to see if we're over the limit, and if we're not, we'll go ahead and add a brand new instance of the shrapnel struct, randomizing what the colors of the 4 pixels it will have, and also randomizing its vector. And then I loop through all the shrapnel I have so far and I just move them. All the shrapnel will stay in the sky, so I just erase it with blue. I update its position, and I am updating it by the pixel and not by the byte, so that complicates the arithmetic a bit. And then I draw the 2 by 2 shrapnel box in its new position. Once a piece of shrapnel goes out of bounds, I delete it from the array, making room for new shrapnel to be added. All right, here we go. Boom. Okay. No big surprise there. Looks like we have a bug. Well, I definitely found something. One of the psychological disadvantages of using these newfangled structures and fields is they can make it look like your instruction is complete because it's so full, even though it's not complete. That is supposed to be indexed addressing. This merely gives you where the field lives inside of the structure, but this is actually pointing to the structure. So I need to add this to this in order to properly initialize these offsets and anything else. But I think these are the only places that I screwed up. Okay. Oh, there we go. It doesn't look like things were actually getting erased and it's going way too fast. But that was kind of interesting. I've made a few tweaks. Let's take a look. Yep. Okay. All right. I kind of wonder if maybe it was better to have it not erase, even though that was a bug. Would it be more dynamic if it just didn't erase? Let me just try doing that again. Yeah, I think maybe I do prefer that. And here it is again with the extra weights added back in during the compression. Yeah, I think that's okay. I don't know, maybe you guys have some better ideas as to how to make this a bit more dynamic. Obviously sound, but that's for later. If you have any visual ideas, let me know. Next time there's an optimization that I have been postponing doing for a very long time that it's finally time to do. Until then, thank you for watching.